OSI Layers. OSI stands for Open Systems Interconnection, a conceptual framework for how applications communicate over a network. These are the 7 OSI layers: the application, presentation, session, transport, network, data link, and physical. Application layer allows software to send and receive information and present meaningful data to users. Most of what the user actually interacts with is at this layer. Web browsers and other internet-connected applications like Skype or Outlook use Layer 7 applications protocol. The Skype, or as a network-connected application, uses protocols like Telnet. If you send your friend a picture of your cat, Skype would be using the file transfer protocol. Presentation layer defines how two devices should encode, encrypt, and compress data. This layer converts data to and from the application layer. In other words, it translates application formatting to network formatting and vice versa. This allows the different layers to understand each other. This layer receives application data from layer 7, translates it into binary, and compresses it. When you send a message, layer 6 encrypts that data as it leaves your network. Then it decrypts the data when your friend receives it. Session layer establishes and terminates connections between devices, determines which packets belong to which text and image files. Applications like Skype consist of text files and image files. When you download these files, Layer 5 or Session determines which data packets belong to which files, as well as where these packets go. Layer 5 also establishes, maintains, and ends communication between devices. Transport layer, responsible for transmission of data across network connections. This layer coordinates data transfer between system and host, including error checking and data recovery. TCP and UDP are both very well-known protocols, and they exist at layer 4. TCP favors data quality over speed, whereas UDP favors speed over data quality. Layer 4 or transport receives data from layer 5 and segments it. Each segment or data unit has a source and destination port number, as well as a sequence number. The port number ensures that the segment reaches the correct application. The sequence number ensures that the segments arrive in the correct order. This layer also controls the amount of data transmitted. For example, your laptop may be able to handle 100 Mbps, whereas your friend's phone can only process 10 Mbps. Layer 4 can dictate that the server slow down the data transmission, so nothing is lost by the time your friends receive it. But when your friend sends a message back, the server can increase the transmission rate to improve performance. Network layer transmits data segments between networks in the form of packets. This layer determines how data is sent to the receiving device. It is responsible for packet forwarding, routing, and addressing. Layer 3 or network transmits data segments between networks in the form of packets. When you message your friend, this layer assigns source and destination IP addresses to the data segments. Your IP address is the source and your friend's is at destination. Layer 3 also determines the best paths for data delivery.
Data link layer translates binary or bits into signal and allows upper layers to access media. A MAC address is a hardware identification number that uniquely identifies each device on a network. Layer 2 or data link receives packets from layer 3, whereas layer 4 performs logical addressing IPv4, IPv6. Layer 2 performs physical addressing. It adds sender and receiver MAC addresses to the packet to form a data unit called frame. Layer 2 enables frames to be transported via local media, example copper wire, optical fiber, or air. This layer is embedded as software in your computer network interface card or NIC. In short, Layer 2 allows the upper network layers to access media and controls how data is placed and received from media. Physical layer, responsible for the physical cable or wireless connection between network nodes. Actual hardware sits at this layer. It transmits signals over media. This layer converts the binary from the upper layers into signals and transmits them over local media. This can be electrical, light, or radio signals. It depends on the type of media used. When your friend receives the signals, they are decapsulated or translated back into the binary and then into application data so your friend can see your message.
In application, apps like Skype uses Layer 7 application protocols. In presentation, it translates data to binary and encrypts or decrypts it. In session, it establishes, maintains, and ends communication between devices. In transport, it segments data from Layer 5. It ensures data arrives correctly and at what rate. In network, it transmits packets between networks and determines best path.
In data link, it adds MAC addresses to the data packet, letting upper layers access media. In physical, converts binary into signals and transmit them over media.